Alright everyone, so welcome to this second module, and I'm going to be going through the data science life cycle. And this is very important and vital for handling any data science task. What are the different stages? So you need to understand this. The first is the discovery stage, and this is where you actually get to define what you want to do. You get to define the problem you want to solve, right? Then you also get to define what you want to achieve, the solution, also your hypothesized solution. Then after doing this, you have to sort out the kind of data you would need to work on to achieve this. If you want to work on a movie recommendation system to be able to recommend movies for people and you want to practice something out, the kind you have to get a data set that is tailored to these needs, and your data set will obviously be a movie data set having hundreds or thousands of movies, ratings, comments, reviews, and all of that, titles, the year they were produced, and all of that. You won't go for a data set having cats and dogs. No, you go for a data set tailored to meet your need in order to solve that problem and come out with a good solution. And also you have to identify the and discover what kind of algorithm you need for that model, right? So if you are given a movie data set, you would have to sort out the movies. Okay, should I start analyzing movies from 1800 to, for instance, if there are movies there that actually produced 1800, should I start analyzing movies from 1800 up to 1960, or should I start analyzing movies from 1960 up to 2020? So you can actually have all those data, and you can get to I will explain this thing. I will explain this in when we get to preparing and cleaning and exploring data set. And so you can get to remove um, and separate your data. You can remove those features you don't want, like all movies that started from 1800 up to 1960, remove. So you just be left with movies from 1960, or if you want movies from 2000 up to 2020, you can actually do that. So you can get to sort your data, what you actually want, allow the features to remain, then explore this data, get the similarity level, use the ratings and the likes to actually work on and build your algorithms and all. So that's what you do at the discovery stage. What do you want, right? Then secondly, after doing that, you obtain your data, and most of your data set, they come in Microsoft Excel format or CSV format. All right, and there are different ways to okay, I'll talk about loading your data. So normally the most popular platform for obtaining data sets, the most popular one is cargo.com, right? And in cargo.com you get to obtain data sets and source them. You can download them, and I'm going to explain how you work with libraries. So you get to use your Python programming tool, your language, your Python programming language, as a tool to load these data so you can display them. And we're going to be using a beautiful software um, package and all of that to be able to visualize, explore, and analyze data. So after getting your data, you load in your data, you read in your data, so you can see all the movies. You'll be able to see everything right on that software. So you use Python to do that. So you can see how Python applies here. Then also you can get data through a web scraping tool. One of them is, there's a library for that already. There is a library called scrapy, and there's a library called beautiful soup. Yeah, beautiful soup. And you can use beautiful soup as a library, or scrapy, for actually crawling the web. You can actually crawl a web page, scrape pictures, images, or any data you specify, depending on what you want. You can actually scrape data from the internet. Then, of course, when you scrape data, you will get a messy data, different values, data types, missing values, and all of that. So you have to prepare and organize this data, right? So different formats, so you have to bring everything to the same format. So there's really a lot of work to do when it comes to cleaning and preparing data. So basically, under this obtaining data, you just get your data, you just source your data from different databases. And you can also use Facebook or API if you want to get data on like history, comments, or different things. You can actually use a Facebook API, right? Application program enable interface, or Twitter API to obtain their data from their database for if you want to analyze those things. Then the third step is to prepare and to clean your data. And in preparing and cleaning your data, you should note that your data usually come, of course, data raw, it usually comes raw. And since it's raw, it's usually messy, right? And of course, processing data results in structured and organized information, right? So your raw data, they usually come messy. So you need to tidy up the data. There will be lots of missing values, right? So you will need to fill in those values, because if you leave them missing, it's going to affect your accuracy. And so there's a way to actually um, cite these missing values and fill them with values. And you don't just fill them with any values. There are ways to do this. You can fill them with the mean of that column. It's possible for you to have a column, for instance, and the feature name of that column is named age, right? And from the range, you had people around 13, between 13 to 19 years old, and suddenly among maybe 1,000 rows in that column, you had about 15 15 missing rows. You couldn't identify the age of 15 persons there. So there's a way to actually go about it. You get to fill those missing cells with values, and you can either find the mean of everything, the mean of the all the rows, all the cells in that column, and fill all the missing cells with the mean of everything, or the median of everything. So it depends on what you want and how you want to go about it. So next, you get to remove some columns you don't want. For instance, you might have a data set with different columns like age, place, state, cities, locations, review, ratings, and all of that. And okay, you don't really need, if you are going to work on geographical, you want to be able to analyze and give your results based on geographical analysis, then you need columns like You need colons like states, cities, and locations. So, and you may probably need age, but maybe if you talk about price and all, you may not need price. You may need price. So you just get to remove those colons and allow the ones you just want to analyze to remain. So there's a lot of work here, and a very beautiful library for analyzing and preparing data is the Pandas library. All right, the Pandas library allow you to load the data into a data frame, so you get to see all the data in rows and columns, and you get to analyze your data, sort your data in ascending descending order. You get to sort everything and clean your data there, right? You get to cite missing values, you get to fill missing values, you get to merge columns. So that's your data frame and all of that. You get to split columns, you get to transform from one format to another. So you will use pandas a lot, right? You use pandas a lot, and I'll talk about that later. And I gave an example here. For example, for the place of origin, you may have maybe a place of origin colon, you may have city and state joined together, or you may have city and state, right? So it depends on what you want. You may either want to join city and state together to have something like um Ota, Lagos, just in one column, and all then different rows having their respective cities and states. Or you can actually separate them into two distinct rows, like a row for cities and a row for ants, or no, into two different columns, a column for cities and a column for states. And remember, a row is the horizontal line, and a colon is a vertical line, right? A colon has and contains many rows, right? And a cell will refer to each of the boxes where a colon and a row meets is called a cell. Then another is for exploring your data. So you need to understand the data, right? You need to explore the data, understand the data, examine your data. This way most of the work is um, will actually need to be done. After preparing and cleaning your data, you will then need to explore your data, because your data is now ready to be explored and examined. So you will now need to examine your data depending on your need. So you examine your data to discover patterns, insights, and relationships. For instance, you may want to discover the relationship between people actually buying on the website and people actually and the age of those people. So you might discover that the people that have been buying on your website, after filling in for some information, like before they buy, they will get to fill their age range, their names, email addresses, location, and all of that, right? Then when you're analyzing the data, you may get to find out that okay, there's a relationship between the age range and the price. You get to see that okay, people that have been buying on my website, they've been above 25, so I should focus on people above 25. Then you get to see people below 22. They are just fans on your website, they are not really buying, they are just there looking for freebies. So you get to sort out all these things and understand the relationship. Then you get to inspect your data and its different properties. And in your data, you find out that there are three different data types. You have numerical data, categorical data, ordinal and nominal data. And for instance, you might have a column like location column. You have Delta State, um, Edo State, and all of that. But your data would love to will work best when you bring everything to a numerical level, a numerical format, a numerical data type. So there's a way to encode all these things from whatsoever format and data type they will be into numerical format. That is called feature engineering. So in feature engineering, you get to create new columns for better model results. And feature engineering is the process of transforming raw data into features, right? So better represent the underlying problem for to the predictive models to improve, resulting in an improved model accuracy. So for feature engineering, it's about creating new input features from your existing ones, right? You will not want to just manipulate and spoil a column. So you will want to create to duplicate that column, work on that column to suit your purpose, to suit what you want, to suit and to aid better analysis and treatment. So that's feature engineering. Then your model creation. So you have your historical data, right? Then you will now, so what you do, you divide them into, normally after obtaining your data, defining your problem, obtaining your data, this is where you have them. Then after cleaning your data, exploring your data, you get to, you save it, right? Then you get to sort them out. You get to divide and split into training data and testing or validation data. Then the ones in your training data, you use them to train your model, right? To train your model. Then you get to hyper tune some parameters in your model, and as you train, depending on everything, then you get to evaluate your training results here. Then when you want to test the accuracy of this your model after training, right? You have a new test data. Your model has seen this one but has not seen this data. So you can actually, your model can actually, this validation data can actually go inside this model because your model has not seen this one before. Your model was not trained on this one before. But seeing that they are coming from the same place and it was trained on this, so it should be able to tell what is this with the knowledge of this. You train this with yellow, blue, red, so it's able to understand and recognize colors and identify different colors with their names. So it should be, when presented with purple here, or maybe if you train it with purple, when presented with purple here, you should be able to tell, okay, this is purple, right? So you get to analyze and evaluate your results and all of that. So working on your model, you get to clean and exploring the stages. So both cleaning and exploring, right, they are very crucial for building useful models. So you take your time on those stages before jumping right to the modeling session, and you get to train your models to perform classification, to differentiate emails when you are working on classification and all of that. So you should see that not all features or values are needed when predicting for your model. So you have to select the relevant ones that will contribute to better prediction accuracy. So we've explained this before. This is this is one algorithm is called logistic regression, and you can use it to differentiate between inbox and spam. You can use it to forecast values using linear regressions, right? The relationships and all of that. In short, we can use regression and prediction to forecast future values and classification to identify and clustering to group your values. Alright, so you basically work on regression. So when you talk about regression, you're talking about forecasting future values, forecasting future values for your data. Right? Then lastly, you after doing everything, you need to communicate your results. You need to communicate your results through using different visualization tools like your matplotlib your Seaborn, Power IBI, and all of that. So you get to visualize your findings accordingly, keeping it driven by your business questions. So that's the essence. After working on the data, the model, and everything, you have insights, right? So what the company is interested in is you bringing the results, what to the table, you bringing solutions to the table. What should they do? Should they increase their budget? Should they focus their marketing on this geographical region? What should they do? So you have to communicate that this is where you actually get to do bulk of the work, because you have to present your data very well. So thank you. We're going to be treating the libraries soon. All right.